Hello YouTube, let's pick up where we left off last time, which was at the very start of this chapter, evaluating expressions. Last time we built a parser to take in a sequence of tokens and spit out an expression, which is basically an abstract syntax tree, and we can print that out, but we can't evaluate it yet, so that's what we're going to do now. And let's see what we should do. So first of all, he's talking about how do we represent values. So this language that we're creating is a dynamic language, which means that the value of a variable can be of any type, and it can even change type. So the question is how we represent that. Now in Java, he wants to use just an object type, so any type in Java, I guess, derives from object. We will probably use an enum that will contain all the possible types, I guess. Let's have a look over here. So yeah, these are just expressions and they can hold. Yeah, we'll see how it goes, but probably we'll use an enum that that will just have all the possible types. Okay, so what we want to do now is to start our interpreter, and we will basically, I think, do the same that we did here when we said toString. Except we will say something like evaluate, why not? And what should it return? It should return like a proper value. So right now the only value type we have is this literal. So I am not sure. So for now, we will do this. Now obviously this will not work always, I think, because I mean, not everything you do in a program is a number, a string, a true or false, or nil. I mean, I guess you could say that things with side effects, that without return values are just returning nil. But I don't know. This will be good enough for now since we're only supporting numbers, and then when we start supporting other things, we might have to change this. Okay, but anyway, so again, we kind of dispatch on the type, and if it's a literal with some value, then we can just return that value. So that's pretty easy. Now, if it's a grouping which has like a sub-expression, then we can simply evaluate that expression. Okay, that's the same that's happened here. Here we go. He's using this visitor pattern again. So if we go to a literal expression, it will return the value. If we go to a grouping expression, it will evaluate the inner expression, which is good. Sure, whatever. Okay, let's go to the Unary type. Be a little bit more complicated because we have to do different things depending on what the operator is. So let's say the right is it's an expression, so we can, but it's a boxed expression, so we probably need to dereference. So we can dereference, evaluate, and oops. And once we've done that, we can, okay. So this will just be a literal value, but it could be a string, Boolean, or so on. And actually, it's not really handled here, right? Yeah, I'm wondering what happens if the cast fails exactly. Okay, so it's just not finished yet. So let's look at the operator type, and if it's minus, we will try to what will we do? The problem is that we will have a lot of annoying match statements. Maybe this is what we should do. So the operator itself can have these values. Let me zoom in, maybe. Should remember to do that. So it can be a number, string value, true, false. So if we get a number with the value x and the operator is minus, then we will return, it has to be a literal value, so we'll return number at minus x. Okay. Now, if it's anything else and minus, then probably this should be, again, a result. Now that's fine. We will break here, and this one will just be okay. If it's anything else, then we will return an error and say minus not implemented for and then we will do this. Okay, so that's pretty good. Let's keep reading. Because now the interesting thing is, let's say, no, it's never mind. Okay. Then we will say now anything and the bang token. Then we will, actually I don't need this. So in this case we will do the same thing as here. So how do we do that? So we don't want to return like a raw boolean, right? We want to return a literal value. So one of these, which means that we cannot use the built-in not operator. Maybe we can, but let's instead make this function. And for now, just say not implemented, or rather just to do. Okay, so, and actually I want to, we can just do this, make it a method or whatever you want to call it. So let's add it up here. It will be public, it will be in the proper thing, and it will return also a literal value. So now I'm not sure how he will do it. Okay, I don't know exactly what will happen here in Java, but we will say something like this. Okay, if it's a number, then it will be false if the number is 0. So we will say if x is 0, then we will return false. Otherwise, true. Is there inline like this? No, wait, so we have to return whether it's false. So here it should be false, and here it should be, okay. That's not going to be confusing. So now we will say, is the length of the string 0? If it's 0, then it's a false value, otherwise it's not a false value. If it's true, then it's not a false value. If it's false, then it is a false value. If it's nil, then it's a false value. There we go. Let me see. Okay, there's just no ternary operator. So we have to do if this, then true, else false. Same here. Okay, format is a little bit annoying, but whatever. Let's try to check it, and it did not work. Yeah. We already have some functions down here. Let's say use the raw value or the variance. Let's get this guy away from here, down here. There we go. Let's try to check it. Okay, so let me now, yeah, that doesn't matter. Okay, this is a good point. So this reference check doesn't work. I mean, can I just do this? Right, it's called a grouping. And we really have to do this. What's the problem here? Okay, it found a reference. So can we just dereference it? And now we also have to rename this guy. And right. So this has to be an OK. Maybe there's a better way to do it. And this will also be an OK. And didn't like that, so we format it. And it's not, display is not implemented, so we will debug display it. Okay. We will just add that now. Yeah. And we renamed it to the snake case convention. Now we're back in the warning land. No, not quite. Unreachable pattern. Huh. Right, so if I do this, will it then complain? Yes. Ah, maybe it's complaining about this. So anything else we will say to do. Can I clone it? Right. Okay. Can I now turn this one on? Let's also add token type. No, it did not. Where is the problem? Do we have, don't we have toString? We have toString for literal value, so let's use that instead. Where were we? We were around here. So toString, and we don't need a debug when it's a string. What happens if I do this? Interesting that this match statement moves it. That's very interesting. I don't really like it, but it really shouldn't be necessary. Can we do something like this? Apparently. So can we just test this? We can, let's go to main, and now we don't just, let's say the result is this, and then we will just print the result instead. Let's try that. Now, we cannot do a lot, but we should be able to do 1. We should be able to do -1. And that's it. But it seems to work. So, we can also do the bang. So we can do like not true becomes false. And we can do not nil as well, and we can do not empty, and if it has something, and we can do not 1, not 0. Okay, so it works. Now let's do the binary. Let me open it up so we can compare. Okay, so if we have a binary with a left, an operator, and a right, then we want to do something. And what we want to do is okay, so we need the left value. We need the right value. We need to check on the operator. And actually, we need something else. We need also to check on left and right, I think, because let's say we have a number, we have plus, and we have another number. Then it's quite clear that we should return x plus y. In the same way, let's say we have this with a minus, then it should be x minus y. But now let's say we have something else. Let's say we have a string value and a plus and a number. Then we can return an error, or we can do something. Now just let's keep up with the, so he's just casting everything to here, to two doubles, which means it will fail. And okay. Okay, a little less error handling. So let's say if it's a string and a number, then we will return an error. Cannot operate on inconsistent on string and number, whatever, to string. Fantastic. Now we have to do the same thing. Yeah, we don't need these anymore. Away with them. And the same thing here, if it says just in the other way, can return the same. Okay. Now, but if it's a string value S1 and it's a plus and another string value, then we do want to do something. Actually, we want to make a new string value. We wrap it in OK. We make a new string value, which is, and now I forget how it's done in Rust. I guess we can just do something like this. S1, S2. Okay. Now what else could we want to do? We also have the division operators. Let's add them up here. Division, multiplication. Let's do it in this order. And what was that called? Go in the scanner. Go to minus. It's probably somewhere around there. It's just called slash. This one is called, sorry, star. This one is called slash. And I think that's about it. Let me see if he has something I forgot. He starts with minus, then slash, then star, and then the plus. We can separate this a little bit more. Maybe we can do something like this. So we have the numbers on top, then we have like mixed here, and then we have strings. And right, then there's also comparison operators. And so we have for number types, we need for greater, greater equal, less, less equal. Okay, let me see here. So not here, no, expression. Now I want an extra function which just takes a Boolean and returns a literal value. So we will say if B, then return true, otherwise the false value, because now we can say it's quite verbose, but it will work. Okay, format, it works, no syntax errors. Great, what else? And let's continue with the same pattern. If it is a bang equal, then we will return OK. Literal value bool, and it should be this. Perfect. Now we can also evaluate expressions, at least a little bit. Let's see if it works. Didn't work. Let me run it in here instead. So we have an error on line 149. Because these have to be numbers, of course. Okay, this one will be a to-do. No warnings anymore, no errors anymore. Try again. Okay, 1 plus 2, that works. We can do ABC plus DF. We can do something like this, it should not work. We just get the error message. And you can see here the benefit of having all of these cases written out explicitly like this is that now we could say, for example, we could even like get the token, the operator. Let's call it up. And then we can say this token type is not defined for string and number, and we need to format it. Something like this. Okay. Then we will say plus is not defined for string and number. And we can also say this, then we'll say minus is not defined. So I think that's pretty nice. So let's do the same here. And this, way of writing is also suggests that maybe you can define like operators that only work in one direction. Don't know why you would, but like maybe there's some operator where string on the left and number on the right makes sense. I don't know. You can think about that. And we also would like the equality operator for strings. There we go. Let's see if that stuff works now. A equals A. That failed. Because we need equal here. We need bang equal. Oh no, sorry. No, that is what it's called. That's true. That's false. That's true. Oops. That's very good. What am I doing right now? Stopped. Let's get it out. And then... Okay, there we go. One of the corners where the details how we represent logs in terms of Java matters. We need to correctly implement logs, which may be different from Java, sure. Yeah, so there's a lot of cases that we haven't handled explicitly. Because we could have false, we could have like booleans on either side, we could have nil. So we really want to get rid of these to-dos. But actually I think we will stop here for now, and then next time we will finish this evaluator code.